Hi, how's it going? Working on some modifications to this Jewel Thief hub charger, which I'm going to show in the next video. This video is going to be about measuring the watt consumption of an LED in a circuit. I don't want the information to discourage anyone from building a Jewel Thief or a pulse motor. They're fun to build and you can learn quite a bit from them. And I still think we're getting very close to achieving over-unity once we remove some of the inefficiencies in it. My last video I wasn't too sure about measuring the wattage for a LED by measuring the volts across the LED times the amps. So I put together a small experiment with charging a battery, and I'm going to try a light bulb, an incandescent bulb in series, and get some watt measurements and see how they add up as far as the input goes. And I'm also going to do the LED in series. I'm starting out with 11.85 volts in the battery. And because the LED doesn't limit current, in all these tests I'm going to limit it to 220 milliamps. I'll fill in these measurements when I edit the video because some of these readings are going to be jumping around. So we have the 220 milliamps going in and 11.9 input and the battery. And I'll switch this around to the incandescent in series. I have the incandescent bulb in series. This is the volts across it. And we're starting out with the same voltage. I drained that down a little bit. And we have our 220 milliamps in. And notice the voltage is much higher in the supply now because we're going through the incandescent bulb. I want you to take notice of how bright that is. You should be able to compare this on the camera as compared to what the LED is going to be. Now we're going to look at the LED in series. And notice how much brighter it is. About blinding me. Across the LED we got about 8.4 volts. And I believe the voltage came down in the supply. That's a lot more light than what that incandescent bulb was. I have one more test to do, and that's with the LED direct to the power supply. And same 220 milliamps and 8.4 volts. This LED that I'm using is rated for 10 watts. And the bulb that I use is a 3.7 watt bulb. Now if I were to use a bulb that's the equivalent of the LED at 10 watts, there wouldn't have been any light from this bulb. This test might seem kind of ridiculously simple, but It has some pretty interesting results. In each of these tests, the battery voltage started off at 1185, so it's the same for each test, and the battery voltage and wattage consumed was the same in all three tests. Now, in connecting direct to the battery, we had the same amount of watts going into the battery as we applied to it, which was kind of expected. Now, with the incandescent bulb in series, we had to apply more voltage. As you can see, the watts are pretty much the same. It's off by a little bit because of my meters probably were a little off, and I also rounded these numbers. So we had 50% of the watts stored in this case. Now, with the LED in series, we used a little less voltage than the incandescent, and you can see the watts put in are pretty much the same as the watts going out, consumed. So there's no difference in the efficiency as far as charging a battery with an LED in series, other than the fact it's going to require a higher voltage because of the breakover voltage. I did get 58% of this energy stored with the LED versus the incandescent, so that's an improvement there. But this does show that measuring your voltage across your LED times the current flow is going to give you the watts that are consumed in the LED. The other energy that's consumed in a circuit, which normally with LEDs you have a resistor there, you're getting consumption there. Like I mentioned before about with the LEDs, as far as heat goes, there's a hot and a cold threshold on an LED. Here we have the LED has less watts consumed than the other resistance in the circuit. So this is running cold because we're below the other one. And like I did in some of my other videos with a motor in series with an LED, if you have too little resistance here, the voltage will shift over to the LED, and you're going to start getting more consumption in the LED. When that happens, you're into the heat cycle for the LED, and you're wasting energy. That energy that you would be wasting as heat could be captured in a battery. So we're not, in all these LED replacement bulbs, we're not totally using the maximum efficiency we could on the LEDs. Which brings me to another subject after looking at this. Yes, it took more voltage here to be able to accomplish this. $120-volt source. If we remove those resistances in the LEDs, we have a potential to charge batteries. The other thing is the last test I did with the LED direct to the meter. It was the exact same reading as it was in series. This is a section of a 4-foot LED light strip. You notice all the resistors that are in here controlling the current. Each one of those is consuming energy. those resistors were all replaced, you would have leftover energy from a 120 volt source to charge batteries. The battery could control the current. Notice in here the voltage has no trouble passing through an LED. We had 20.4 here, 8.4 of it was held up here, the rest of it passed right through and went over to the battery. Should be no reason why we couldn't do that with 120 volt. The LEDs in series would gradually drop down the voltage, and whatever's left over from one would pass on to the other until we get down to whatever voltage is left, and most likely there's going to be enough there to charge a battery. Thanks for watching.